Welcome back. As I gave you the clue on my previous video, we're going to be getting into the world of aromatic compounds through the concept of aromaticity. Okay. Now, we all associate ourselves in a happy mood when we smell something very pleasant, very inviting. And this could be a shampoo, a deodorant, a cologne, a perfume. It could be as simple as a pine sol. Some people even like, glass cleaner and things like that. And what makes them something smells very good is the property of something being aromatic. Okay. And that if you take a compound that's linear chain and it's not aromatic, it has a very bitter or foul smell. Whereas something that contains aromatic ring tends to be more flavorful and more pleasant and inviting. Now, as far as the labs go, we have synthesized orange oil, we have synthesized clove oil, we've synthesized cinnamon oil, and you notice that, except for a couple of you, most of you do like that smell, right? When you can smell pleasant smelling clove, and if you noticed all the three compounds that was in the purpose page of your procedure, you will see that each of them contain a benzene ring. Okay, and benzene ring what gives it that unique flavor. Okay, so without further delay, okay, aromaticity, okay, there are certain rules on determining whether a molecule is aromatic or not. Okay, and before I walk you through the rules, let's look at a molecule that's probably known to anyone that's taken an organic chemistry class, and that's benzene. Okay, what is unique about benzene is it looks plainer, just like the way it's drawn, like it's literally on the plane of the paper, and that's what we call planar. If it has any projection from a paper or a table where you place it, that means it's no longer planar. But what is even more unique about this particular molecule is I would be able to move this bond here, I'll be able to move this bond here, I'll be able to move this bond here, and which leads us to these three lines is not necessarily meaning a triple bond, it just means AKA or something very similar. So we now have this structure, okay, and this can move back into this. So we will end up with what we start with. Okay. Now, no one could really predict which of the time this exists, which of the time it will exist in this form. And that's called the phenomenon of resonance. Okay, that means you cannot really pinpoint and say it exists 75% of the time in this, 25% in here, or 30% here, 70% there. No one can really pinpoint and say, or even no one can even discern like which structure is right or which structure is wrong. So typically you may not see me doing this in an actual reaction, but in a textbook, or if you watch any video on aromaticity or aromatic compounds, you would see people write this because they just give up and said, well, there's no way you can be 100% sure the precise location of these bonds. So typically what you do is you draw a circle with dotted lines indicating that there's a chance that these bonds move around, so it exists in one of the two forms. And that's a very, very important quality for a molecule to be aromatic, is at least one of the quality is the concept of resonance. Now, if you rewind your mind back to a few weeks, maybe a couple of months, when we learned our alkenes and alkynes, I told you that if a compound contains alternate double, single, double, single, double, we called it the molecule is planar. You may not remember it now because it's been a while, but those of you that do remember, you remember that if a molecule contains alternate double, single, that's planar. Okay? A compound that contains triple, single, triple, single, triple, single is linear. Okay? a compound containing like this, each of this is tetrahedral. Okay. Now, what does that mean? That means when a compound contains double and single, each of the carbon in that is sp2 hybridized. Okay. And anything with triple and single alternate is sp hybridized. And anything with single only is sp3 hybridized. Something I have told you, but if you have forgotten, it's time to refresh those knowledge as well. Which leads us to the second quality is it must be planar. A molecule must be planar to be aromatic. That's the second quality. And the only way we can achieve planarity or planar is through sp2 hybridization. And that's the second one. The third thing is the Huckel's rule. So maybe it's time, let's write the three criteria. Okay, the first is, these are not in any specific order. You can go back between the rules, but all three must be met before you can conclusively say that the molecule is aromatic. First one is obviously resonance, which in itself is tied to the concept of planarity. And the third is Huckel's rule. Okay. So resonance is simply being able to move. And the key thing to a resonance is, I'm going to get a different color just to, mark what I'm referring to here is, you see the tail of this bond, it meets the head of this bond adjacent to each other. And that's resonance. If you cannot do this and complete it, chances are your molecule doesn't actually have the property of resonance. Planar, that's this one right here. You must have alternate double, single, double, single, double. Even if at one point you have two single bonds or any other bond, I guess there's only three bonds, double, single, triple. If you have two single bonds, the chances are it's also not planar, and that means it cannot be aromatic. The third thing is Huckel's rule, which is 4n plus 2, and n can take a value of 0, 1, 2, 3, etc., etc., etc. Okay. So what does it mean? Well, you take the molecule that's given. This is 2 electrons, right? This is 2. This is 2. And this is 2. So you have 6 pi electrons, because a pi or double bond is also known as a pi bond. So 6 pi electrons. So you can substitute always some random values out of these first and see. So if you put 0, you get 2 electrons. If you put 1, you get 6. You put 2, you get 10, etc. Right? If you cannot match this number here to a number here, that means it does not obey Huckel's rule, which means again it is not aromatic. But in my case, I got 6 here, which matches this. So that means on all three counts, resonance, planar, Huckel's rule, this molecule is guilty as charged, and it passes the jail sentence of aromaticity, right? So resonance, planar, Huckel rule. Planar because double, single, double, single, double. And resonance, the tail and the head meets Huckel's rule, it matches 6 and 6. All right, and that's all there is to really aromaticity. But in the next video, to keep the video shorter, I'm going to make one more video where I will show you some other examples besides just benzene, where initially visually it may not give you the opinion that it is not aromatic, but in fact they are aromatic. So I'm going to walk you through some of those in the next video. All right, so stay tuned.